Hi guys, it's Talha here again today. So today we are going to study some math, and then after that we are going to study some fundamentals of computers. So now today our topics will be about, I'll discuss what are limits and why we use limits, what are limits. Then I'm going to discuss uh, I'm going to discuss the rate of change of functions rate of change of functions. Then I'm going to discuss about limits of functions and then I'm going to discuss the formulas, different formulas, or different, you can say, rules for uh, limits limits of functions. And then if we have time, so we will discuss some fundamentals of computer. We will discuss storage devices or storage, and then we will discuss storage medium, or you can say storage media. Media is the plural of medium. And then I think that's it. If we have time, if we'll have time, then we're going to discuss this storage thing. If we won't, we will just discuss these three things. So let me start with limits. So what are limits? Limits in mathematical terms. So what are limits? Limits is actually so what are limits? Limits are actually used to when a function varies. For example, some functions vary if you put a different value of x, or if you change the value of x by a little bit. it the function does not vary that much. It varies by up to some extent. But if you for example, there's a function f of x equals something here. So if you vary x a little bit, it doesn't change the function that much. The function also varies just a little bit, but sometimes when you vary x a little bit, this function is totally changed. So a lot of change occurs in this function also. uh, limits limits are basically used to calculate where the result of the function is going to go, at that or you can say about that point where that function was undefined, or where that function did not have a value. So it is limits is just used to approximate the value of a function at the point we want to know. For example, we want to know what would have been the value of this function at the point. But for example, before that point, that function did not was not defined, but we just want to know where would that value be of that function. That is why we use limits. Now let me just discuss what are rate of change of functions. So rate of change of functions. So how do you find the rate of change of functions? For example, you have a function y equals f of x, and you put different values. First you put x1, then you put x2. So how are you going to know the rate of change of function? You're just going to y2 with the value of x2 minus y with the value of x1 divided by x2 minus x1, the same as when you find the slope. And this equals f of x2 when you put the value of x2, and when you put the value of x1 and you divide by x2 minus x1. Now so this was the rate of change. Now uh, So this is how you find the rate of change of functions, where a function varies and you just want to find how much did it vary, or what was the change in it, how by how much change did this function vary. Now let's calculate the limits. Now let's calculate the limits of a function. So how, what is the limit? Okay, so let me just, what is the limit of function? How do you calculate the limit of function? What is the basic logic behind the limit? For example, if you say that there's a function which is defined about x naught, like it is not defined exactly at x naught, it is just defined about it. So at x naught its limit, or this function is not defined, it is just defined about this x naught. So if we want to do the limit thing, we'll say that as this x reaches closer to x naught, like not x naught, if it's x naught, this value is not, its function is not defined, but we're just saying as this x reaches closer to this x naught, or approaches this x naught, then there's it, the function of x, then the function of x, then the function of x is L, or it approaches L. So how can we write it mathematically? We can write it mathematically as f of x, f of x limit. So limit f of x when x approaches x naught, as I stated this value, so x approaches x naught, then f of x, if x approaches x naught, not exactly x naught, but if x approaches x naught, then f of x is going to be L, or the limit. If it approaches x naught, then f of x is going to be L, or the limit of that function. So this was how you do the limit, and this was the basic concept of the limit of a function. Now uh, let me give you guys an example of the limit of a function. So for example, you say that for example there's a function, f of x equal x square x square uh, x square minus 1 divided by x minus 1 So this is the function, and its limit, and the limit of this function, the limit of, you want to find the limit of this function when x approaches 1, here. So there are two functions, one is this and one is this. Limit of f of x equals x plus 1 when x approaches 1. So first let's find the limit of this function. So how do you calculate the limit? You just plot the value, or you just put the value where of x, where the destination is, it's approaching. So it's approaching here, it's approaching 1. So you just put 1 in the function to see if the limit exists at that point or not. So let's put this point. So 1 square minus 1 divided by 1 minus 1, so that is actually 0 by 0, and which is undefined, which does not exist. So here it does not exist, but we actually want to know where will that function be, like what if the value is not 1, what if the value is not 1 but is very very close to 1. Now what would have been the destination of the function if the value is very very close to 1 but not exactly 1, it just approaches 1. So how do we do that? We just rationalize or factorize this function. So we say that so we so what do? We factorize the numerator. So we have x square minus 1. Yep, we have x square minus 1 or and divided by x. So we have actually two here. If we put okay, here you can factorize it by x square, x whole square minus 1 whole square divided by x minus 1. It will actually give you um, x minus 1 and x plus 1 divided by x minus 1. So you can cut out this x minus 1, you'll get x plus 1. So here it's just same to this one. So what does this mean? If we graph this, okay, so first let's put x approaches 1 here. So here it becomes 2, and now here, so we have come this way. Here we have made this, we have factorized this into this. So now if we put the limit of x approaches 1 here, it will actually give us 2. So that means that if we approach to 1, if we would have approached to 1 and the limit wouldn't have and at 1 it wouldn't have been actually infinity, it would have been 2. So at 2 this function is not defined. So how do we graph this? We graph it like for example, x equals 2, x plus 2. So x plus 2 is like this, the graph. Okay, so okay, here, so the graph of x plus 2 is like this, 1 2, yes, like this. The graph x plus 2 is like this, where at 1 this is 2. The function of this function at 1 gives the value 2, but the graph of, okay, let me just go on the next page. But the graph of this at this function, here, graph of this function is going to be, because it is not defined at 1, because at 1 it's actually infinity, the function is not defined. So what it does here, there's an open interval. So this means at this point it is not defined, but it is defined at every point. If we approach this point from this side or this side, it will actually give us these values. But at 1, exactly at 1, this point is not defined, this is undefined. So this was the function of x square minus 1, x square minus 1 divided by x minus 1, y equals this, and this here was the function of x plus 1, y equals x plus 1. So that was the concept of limit. That limit just basically tells us where the function, or where the function is being approached at. So it just gives us an estimate, like where would it have been if the value wasn't, if the function wasn't undefined. So here, on this point this function is undefined, but on the rest of the points on this line this function is defined. Also if there's a certain restriction, or there's a condition where the limit exists. So for example, if we are coming from the right side, from one side, and from another side the values are same. So if here we are getting this value, and from here if we approach f equals 1 from here, you will actually get this function is not going to be defined. And if we approach this undefined function from here, this function is also not going to be defined. So that means that its limit does not exist. Alright, so guys, that was pretty much it about limits, rate of change of functions, as I explained. So let's recall what are limits. Limit just tells you how much of a change or not change. Limit just tells you then an estimate of what the value of function would have been if it wouldn't have been infinity. And here we discuss the limits of functions. We discuss limits, we discuss rate of change of limits, and okay, so I skipped the formula. So there are different formulas uh, for or rules for the limits of the functions. So for example, there is summation rule, where if f of x plus g of x, the limit of if x limit of x approaches uh, 1 or approaches c, for example, f of x plus g of x, then it will be equal to limit of f of c of x plus limit of x approaches c g of x. And then we have the difference rule, where you just change the sign and it remains the same. Then we have the product rule, f of x g of x, we can say dot. We have a limit of f of x approaches c dot limit of g of x approaches c. But in the division case, where limit x approaches c, f of x uh, divided by g of x, here limit of f of x approaches c divided by limit of x approaches c g of x, if and only if g of or limit of x approaches c g of x is not equal to 0, because 0 by is anything divided by 0 is undefined. So these are some of the properties of function. There are also a constant property, where you multiply the function by constant and it separates for the limit of x approaches c to the constant will be separated, and then it will be multiplied by limit of x approaches c to the function itself. So guys, that was it about functions, rate of change, limits of function. And I also explained some of the formulas or rules of function, where you have summation, division, multiplication, and subtraction rule. Thank you very much, guys.